Hi guys, today we will start the module of OOP or object-oriented programming, and we will look at the four main concepts like encapsulation, abstraction, inheritance, and polymorphism. And today we will look at the inheritance, we'll practice it a little, but first of all, let's define what actually OOP is. So the object-oriented programming in Java is a programming paradigm based on the concept of objects. And it actually can contain the fields or attributes and methods or functions to operate on that data. And the Java is a fully object-oriented language, and OOP is actually a core foundation. And what is inheritance? So inheritance is actually a fundamental concept, one of the fundamental. So there are four fundamental concepts, and one of them is inheritance, and it allows a class. We also call it a child or subclass to inherit the fields and methods and behavior from another class, which is called the parent. This is some simple diagram where you can see the several classes like class A, class B, C, and D, where the A class is very top of hierarchy, and this is actually the parent class, and the B and the C classes inherit from the A class using the keyword extends. We will practice it in the moment, but for now you can look at the basic definition of inheritance. So class B extends, and the name of class we are going to inherit. And this is some another level inheritance where the class D inherit the behavior from class C, and this way class D actually extend the behaving from the C and the A, because the C extends from the A, and you can make just much more levels down, and every new child will have more and more fields and methods from the upper levels of classes. And what's important that those classes, the childs are know about the parent, while the parent doesn't know about the children. So child know about parent because it can actually use the fields, the attributes, the methods from the parent, and parent can't use nothing from those child classes. And if it's not enough, the most simple example and the most like thing you can imagine is you and your parents. So you are like the new instance of your parents, and like the a little bit better because you have its own behavior, its own features, and also you have got something, I hope something of best from your parents, and this way you have your behavior and the behavior of your parent. And this is actually how the inheritance works in Java. And this is very important and useful concept because you can reuse the methods, you can reuse the variables from the parents, and when you will build the real application, you will be able to evaluate how actually it's useful to understand this concept and to fully use it. And another word about the OOP, that you can see that it can, if you think deeper about the OOP, about this paradigm of object, you can find, as I once find for myself, that it actually works like everything in real life. So everything in the life is objects, and we interacting with the objects, its attributes or fields, and the programming we use in inheritance, we use in the other concepts we will look at a little bit later, and try to think about it like more philosophic. Imagine some examples, and you will find that it's really cool and very useful for modern programming, especially in the languages like Java. So let's move to practice. And let's implement it in the Java. And to do this, I will create the package, call it inheritance, and create some classes. First of all, I will create the animal, which will be which will be parent class, and it will have some attributes. Let's say color, age, and weight. Also, let's create a constructor. And also let's make some methods. For example, public void it, and move. And for now I just keep it empty, and we will implement it a little bit later. Now let's create some classes that will inherit the behavior from our parent. So let's create the human. I just leave it empty for now. Fish. And bird. And to achieve inheritance, we have to use the word extends, and we're using it right after the name of the class. So after our bird, we are going to use extends and animal. And you can see it's red now because we also have to create the constructor. And important thing for child classes is to fully use the behavior and attributes of our parent. We have also initialize our parent instance, but we will do it on the background using the keyword super. So let's just let IntelliJ generate it for us. And as you can see, it's generated for us constructor with required parameters like color, age, and weight. And here the first line, the super, with the super we actually call the constructor of our animal class, and creating by this line, creating on the background the instance of our parent needed to make our child work. So let's do it. Let's do the same for the rest of our classes. Not the bird, but the animal. And like this. What's going on? Yeah, we have to insert super. It's not working. Okay, let's do it manually. Now let's move to the main class and create some instances. So let's create human. Let's make it light, age 10 and 25 kilos. Let's do the same for fish. And bird. And as you can see, we pass in here the parameters which are required for creating instance of our parent class. And if you type, for example, human, this is later, with dot, you can see that we have access to color, age, eat, weight, move, and whatever it's going on in, or whatever it's implemented in our parent class. So let's make it, for example, color, and let's say black. And as you can see, at the definition of our instance, we choose the light color. Here we reassigning it with the black, and let's print that look the color of our human. Black. So as you can see, all the parameters we defined in our parent class animal are available for all the instances of classes which inherits the behavior from the parent. So all the human instances, fish instances, and bird instances will have available to change, read, and write the parameters of our parent class, but also in case if it's public. So actually it means that I want to also explain you the access modifiers. Firstly, I plan to explain it in separate lesson, but then I decided it would be better to merge it with inheritance, because some modifiers are better to show actually with inheritance. So as you can see, everything we have in our parent class is public. So color, age, and weight. And what if we make, for example, what if we use different kind of access modifier? So first of all, let's define what types do we have. So we have the public, then we have protected, default, and private. And before these lessons, we used to work all the time with only public access modifier. And public, as you can guess, means that the variable or method is available through the whole application everywhere. If you create in the instance or object of some class, you can use all public methods and variables of this class. So available everywhere. Yes, instance required. Actually, all the access modifiers I'm explaining now, it's about to create an instance, and the difference with the static variables or methods is that the static can be called directly with the class name and method or variable. When not static variables, you have to call only through the instance. And what if we will make our age for example, protected. So we changed it to protected. It's still be required in our child classes because it's required parameters to initialize the instance of our animal. As we create in the custom constructor, it by default becomes the main and default constructor to initialize our animal. But now if we will try to find what actually we changed the age, yes. And now you can see that age is not available because it has protected access in inheritance animal. And this is exactly how does protected works. So the protected variables and methods are not visible even for child classes if we trying to access it from different package. And the main class, as you can see, it's outside of our inheritance package, so it's not allowed to call this variable from outside the package. And to show you that it works, we can create some method. So for a bird it can be, let's make it sleep, just to show you that it works. It was age, yes. And we can access here age, and you can see that age, protected int age from the animal parent, is accessible in our bird class because it uses extends and because it's in the same package as our parent. So outside from the parent it's not going to work. So the protected access modifier is available in the same package and for child classes or inheritors. Now let's just change it back to public and let's move to default. And to define our variable, to make our variable default, we're not using the default keyword, but we have to delete the access modifier and leave it like the data type and name. So in this construction means that we are not using any of access modifiers, and this has default access modifier. And as you can see, we have the same problem in the main, and it also will be accessible in our class because it's in the same package. And what is the difference between default and protected? To understand the difference, we will move our bird outside of our package. So let's just grab it and move to src. Refactor anyway. And as you can see, now our age became red. Because to use default access modifier, we must to have all the classes in the same package. So if I change it back to protected, you will see that now it works. So for protected, we can also use the protected variables and methods for inheritors from outside of the package. while using default, we must to have the class, the child classes in the same package as parent. So if we remove it back, you will see that age is not public in inheritance animal, cannot be accessed from outside package. And this is exactly the difference. And let me just move it back. So default is available only in the same package for child classes. So the difference is the default requires strictly to have the inheritors in the same package. And if we talk about the private, so let's just make it private. And now our age not going to be available for our inheritors at all. So the private access modifier means that this variable is available only between those curly braces, so only for the class where it's defined in. So doesn't matter packages or inheritance and so on, private is not visible at all. There are ways to actually work with private variables, but I'll show you a little bit later. For now, just let's make it back public. So the private is available only for class of definition. And now let's just remove this and look at the methods. So let me just also remove this sleep. So our child classes can use not only the variables but also the methods which are public, eat and move in our case. And let's implement, as you can see, our move. We can leave it actually empty and implement the behavior in our classes, in our subclasses. So let's, in the human, implement our move method. And to do this, we have to use the override word. And you can see that it helps us, suggest us to override the it, but we are going to use first move. And the move is we are overriding the behavior of move method from our animal or parent class. And what is important is to actually have the same access modifier, have the same return type, the name, and the parameters. So if we make it, for example, string, you can see that it's not working because of incompatible return type. So we strictly have the same method definition as in our parent. And let's here just print I am human and I am walking. And let's implement the same for the rest. So override public void move, and I am fish and I'm swimming. And for bird, I'm bird and I'm lion. And now let's call for every instance, let's call the move method. So human, fish, and bird. And let's print it. And as you can see, we have the different implementation. So we have the different message from every instance of our classes, from our child classes. And that means that we actually inherit the method and implement it in the way we want. And this is the strength of inheritance. So you can define, for example, some abstract thing and implement it the way you want. So you can do just whatever. In this case, like you can create the meal and then inherit, for example, pizza, pasta, or something else, and implement this object in absolutely different way, but with the parent behavior. And let's implement our eat method in the parent. So let's make I'm a human and I'm eating something. And let's try to print our eat. And as you can see, our human class uses the behavior and the implementation of the eat method directly from the parent. But if we will also override this eat method and write something like I'm a human or I love meat, something like that, and print it, you can see that the definition and the implementation of our eat method in our human or our child class have overridden the implementation of our parent. So this statement is not printed because our human choose to print or choose to use the implementation of its own instance. So this way we can actually whether use the methods and some definitions, variables or values directly from the parent, or we have override the methods with own behavior. And our animal class actually doesn't know about the about its children existence. So the human, fish, and the bird knows about the animal, and the animal doesn't know about the existence of those three guys. So our child classes actually can and should have its own methods, its own variables, so we can define something like for example country, and we can also add it to constructor, but our country will not go to super because the super or animal constructor doesn't know about the human and don't need parameters to define the instance of itself. So it's independent of childs, while the childs are dependent of parent. and let's initialize it. And here we have to add here new parameter. Let's make it USA. So child classes uses its own methods. So we can create something like also drive car and add some implementation. We can create the variables, methods, just whatever we want, and also use the features from our parent, while parent only has what it has and doesn't know about the children. And actually we can also do some trick like define another human and create new animal. No, sorry, opposite. We have to define the animal and make it the human. And as you can see, it's required four parameters because we create in the instance of, so we define in the animal, the parent, but we specifying that we are going to create the instance or child of this class and assign it with instance of human. So let's make it 20. Okay. Something like this. And this is actually how inheritance works and how does it look like. And this is very useful tool. It's not so commonly used in the modern development because it has its weaknesses. We will talk later in the course. But for now, it's very nice. It also has its strength, and you can see the strength right on this example that it's actually can use the methods from the parent, and sometimes it's really very useful. And this is it for this lesson. If you like this video, please click the like button. Don't forget to subscribe on my channel. And if you have any questions, leave it in the comments. And I see you in the next video.